Okay, so for the factor theorem, if p of x, so some polynomial function, is divided by the quantity of x minus a, and the remainder is 0, then we can conclude a bunch of things. We can conclude that x minus a is a factor of p of x, okay. We can conclude that p of x is divisible by x minus a. We can conclude that a, or let's do this, x equals a, is an intercept, or sorry, is x-intercept, an x-intercept of the graph p of x, and x equals a is a root or solution of p of x equals 0. Okay, let's go back and let's look at the last independent problem we did. It was 2x to the third minus 7x squared minus 8x plus 16 divided by x minus 4. Okay, just as a refresher, I'm actually going to divide these both ways. I'm going to do long division and I'm going to do synthetic division. So let's do the long division first. Remember, for the long division, whatever's getting divided goes on the inside. So we are 2x to the third minus 7x squared minus 8x plus 16. And we're going to divide that by x minus 4. So we ask ourselves, you look at the first ones, x times what will give me 2x cubed? 2x squared. So now you're going to take that and distribute it into the divisor on the outside. 2x squared times x is 2x cubed. 2x squared minus 4 is a negative 8x squared. But now, remember, at this point in division, don't I have to subtract? But because we're subtracting a binomial, every sign has to be made the opposite. Every sign has to be made the opposite. So then the 2x cubes cancel. So now we're left with x squared, and now we bring everything else down. Minus 8x plus 16. So now you ask yourself, well, x times what gives me x squared? X times x gives us x squared. So now we're going to have x times x is x times x is x squared. X times a negative 4 is a negative 4x. 2, 1. All right. Now we subtract, but when we subtract, what do we have to do with all the signs? make them the opposite. So this becomes a negative x squared and a positive 4x. The x squareds cancel. Negative 8x plus a positive 4x is a negative 4x. And now we bring down the 16. Now you're going to ask yourself, x times what gives us a negative 4x? X times negative 4. So now we have negative 4 times x is a negative 4x. Negative 4 times negative 4 is a positive 16. Because we're subtracting, every sign needs to be made the opposite. So the 4x's cancel, the 16's cancel. Is there anything left to bring down? No. So what does this tell us? Our remainder is 0. So our quotient, our Q, is 2x squared plus x minus 4, and our remainder is 0. Now let's do the same problem using synthetic division. So this was long division. So once again, I'm going to take 2x cubed minus 7x squared minus 8x plus 16, and I'm going to divide it by x minus 4. But this time I want to use synthetic division. Remember, you can only use synthetic division if the degree of the divisor is 1. Meaning if there's an exponent on that x that's bigger than 1, you cannot use synthetic division. Right. Now we're going to look at the dividends. That's what's getting divided. Is every exponent accounted for? 3, 2, 1, constant. We're good here. Now, how do I figure out what number to put in the box? Who remembers how we figure out what number to put in the box? Stefanos? Yep, we take the divisor and we set it equal to 0 and solve. So x will equal 4. And that's what goes in our box. And now you list out all of the coefficients. So we have 2, negative 7, negative 8, 16. You bring down that very first number, and now the number under the line, you multiply with the number in the box. So 2 times 4 is 8. You write that underneath the next number, and then you add that column. Negative 7 plus 8 is 1. 1, now you take the number under the line and multiply it by the box. 1 times 4 is 4. Now you add this column. Negative 8 plus 4 is negative 4. The number under the line gets multiplied with the number in the box. Negative 4 times 4 is a negative 16. 16 plus 16 is 0. Remember, the last column represents our what? Remainder. This is our remainder. So here our remainder is 0. Now our quotient, these are all the coefficients of the quotient. And it's always going to be 1 degree less than your dividend, or what was getting divided. So since this had a degree of 3, the biggest exponent was 3, that means my quotient is going to have an exponent of 2. My biggest exponent will be 2. So this is going to be 2x squared plus 1x minus 4. This is our quotient. And our remainder is 0. We got the same answer both ways, right? So now what can we conclude? That's exactly what I wanted to hear. What can we conclude? We can conclude that x minus 4 is a factor. And we can also conclude that x equals 4 is a 0 or root of the polynomial 2x cubed minus 7x squared minus 8x plus 16. Could somebody tell me what I mean by that x equals 4 is a 0 or root of this? What does that mean? Do you know? So when I say it's a 0 or a root, what I mean is, let's say we have our graph. It means this graph at some point is going to cross x equals 4. So 4 on the x-axis. That's what it means. So whatever this graph looks like, at some point it's going to cross where x is 4. That's what it means when it's a 0 or a root. It's crossing the x-axis at that point, at that number. Okay, now let's talk about the remainder theorem.
So it's a factor because the remainder is 0, right?
It's a factor because the remainder is 0. And then it's a root when you take the factor and set it equal to 0 and solve. That means it's a root. Okay, let's talk about the remainder theorem now. Okay, if a polynomial p of x is divided, this is a different theorem. So the other one was a factor theorem. This is the remainder theorem. So if a polynomial p of x is divided by x minus a, the remainder, and I'll explain what this means, the remainder is equal to p of a. Okay, so let me show you how this works. If p of x equals x cubed minus 2x plus 6, if p of x equals, is divided by x minus 2, what is the remainder? Okay, I'll let you write that down and then I'll explain to you what we're going to do here. So as far as your knowledge goes right now, you can use long division, right, and find the remainder. Can you also use synthetic division and find the remainder? I'm now showing you a third way. If you take the divisor and set equal to 0, then solve. So we're going to take x minus 2 equals 0, so x is equal to 2. Now we're going to plug into the polynomial for x equals 2 and simplify. So this means I'm going to now figure out what p of 2 is. So I'm going to say, well, p of 2 is going to be 2 cubed minus 2 times 2 plus 6. So I took what was going to get divided. I took the divisor, I set it equal to 0 and solved for x, and then I took whatever that x equaled and I went back to the original polynomial and plugged in for x. So now p of 2 is going to be 2 to the third power, which is 8 minus 4 plus 6. P of 2 is going to be 8 minus 4, which is 4, plus 6, which is 10. So this tells us the remainder is 10.
So easier.
Sometimes.
Okay, we just do this all the time.
Sometimes it's easier.
Wait, so then what's
So this, it doesn't tell you the quotient. This only tells you the remainder. So this tells you the remainder. So questions like, is it a factor? Well, we can use that, plug in, and if the remainder is 0, is it a factor? Yes. But if I ask you for the quotient, can you use this? No. So we could really only use this if I ask you for the remainder, or if I ask you, is it a factor? That's really the only time we can use this.
Throw some of those on the test.
I'm sorry?
Just throw some of those on the test.
Throw some of these on the test? Okay, well, let me show you where this really helps. Yes?
Are you like able to use this to like check your answer too? Like if you're using long division and you don't know if it's right, you can just
Absolutely, that would be a great idea to see if your remainders are the same. All right, so let me show you a problem where this really helps out. Is x plus 1 a factor of p of x is equal to x to the 99th power plus 5? So right now, the idea of synthetic division or long division is miserable. Why is it miserable? Because for long division and synthetic division, we have to account for every single exponent. Can you imagine having to account for every single exponent from 99 all the way down to 1? No, that's horrible. But it's saying, is x plus 1 a factor? So what can we do? We can use the remainder theorem and take the x plus 1, set it equal to 0, and get x is equal to negative 1. Now I'm going to take that negative 1, and what am I going to plug it into? The polynomial. So we're going to have negative 1 to the 99th power plus 5. What is the rule? If you take a negative number to an even power, it becomes positive. If you take a negative number to an odd power, it is negative. Well, 1 times itself, however million trillion times, it's always going to be 1. So negative 1 to an odd power is still negative 1. And then we have negative 1 plus 5, which is 4. So the remainder is 4. Is it a factor? Not a factor. All right, 2 more problems, then we're done. Are we drawing? Today? No. Next week. Yes.
Why is it not a factor?
Because for it to be a factor, the remainder has to be 0. If the remainder is not 0, it's not a factor. Okay, so now we're going to find k so that p of x is equal to x to the third minus 2x squared plus 3k, plus 3x plus k is divisible by x minus 2. So notice how I keep changing all the wording. Every problem I've almost worded differently. Okay. If this whole thing is divisible by x minus 2, what does that mean? It goes in evenly, right? So if it goes in evenly, what's the remainder going to be? 0. So essentially I'm saying x minus 2 would be a factor, right? That's essentially what I'm saying. So I need to figure out what k is that will make x minus 2 a factor. what we're going to do, since we know we want the remainder to be 0, I'm going to take this and I'm going to say x minus 2 equals 0, and so then x will equal 2. Then what I'm going to do is I'm going to take p of 2, and I'm going to say I need p of 2 to equal 0, meaning I'm going to plug in 2 into all my x's, and what do I need it to equal? 0. So I'm going to take 2 cubed minus 2 times 2 squared plus 3 times 2 plus k equals, what do I need it to equal? 0. We are now going to simplify this and then solve for k. So 2 cubed is 8, 4 times 2 is 8, 3 times 2 is 6. Am I going too fast? So what happens with the a's? I'm sorry, the 8's. They cancel. So now I'm going to have 6 plus k equals 0, so k has to equal negative 6. So what does that tell us? When k is negative 6, then x minus 2 will be a factor of that polynomial. All right, last problem. K equals 6, negative 6. That's our answer, because it says what value of k, or find k. All right, last problem. So we're going to say find k so that x minus 1 is a factor of 2x cubed plus 2k plus 1 x squared plus 15. Yeah, so you guys tell me. If x minus 1 is a factor, what do we know? We want the remainder to be 0, right? We want the remainder to be 0. So can I use the remainder theorem here to help us find k? Absolutely. How do I use the remainder theorem to help me find k? I'm going to take x minus 1, set it equal to 0, and what will x equal? 1. Now what do I do with that 1? Plug it in and set the whole thing equal to 0. So I need p of 1 to equal 0. So we're going to take 2 times 1 cubed plus 2k plus 1 times 1 squared plus 15. We need that to equal 0. So we're going to have 2 plus 2k plus 1 plus 15 equals 0. So now we have 2k plus 18 equals 0. And now we solve this. Too fast? Am I going too fast?
What about the 1 squared?
1 squared is just 1. So 1 times 2k plus 1 is just 2k plus 1. Does everybody see why I just sort of got rid of this? Because it's 1 times 2k plus 1, which is just 2k plus 1. Okay, so now we solve, and we're going to get 2k equals negative 18, so k will equal negative 9. Okay, we are done. I'm going to post your homework for you.